The best guitars come from trees about 800 years old, trees with enough rings in their trunks to provide wood with a tight and straight grain, wood flexible enough to vibrate, yet strong enough to withstand the pull of the guitar strings. The guitar traveled from North Africa to Europe, with the Moors who invaded Spain in the 8th century. In time, the guitar became the signature instrument of Spanish flamenco music and the trademark of the singing cowboy. In the 1930s, the acoustic guitar debuted as a jazz instrument. By the 1960s, as the electric guitar took over rock and roll, the acoustic guitar remained a staple of the folk music scene. They use spruce or cedar because those woods are lightweight and vibrate well. Using a 30-ton press that works like a cookie cutter, they punch out the shape of the guitar. The size of a sound hole affects how the guitar will sound. The larger the hole, the more treble. The smaller the hole, the more bass. Then they glue on a wood inlay decoration called a rosette. Next, they make the sides of the guitar. They first immerse wood pieces in boiling water for about 15 seconds. Then place them in a heated press to make the curve. The press applies heat from both the top and the bottom for about a minute. Then they connect the two sides with blocks of wood made of either mahogany or poplar. One is glued and clamped at the bottom, the other at the top. Then they glue on and clamp a wooden lining which will connect the sides to the top and back. Those little cuts give it flexibility around the curves. Then, with a hand router, they carefully notch the lining to receive 4 wooden braces to support the back of the guitar. Strategically placed braces help the top of the guitar withstand the tension of the strings. They also equalize sound frequencies by controlling vibration differently at different spots. After a vacuum press makes the bracing adhere evenly, they glue on the top and bottom. The body of the guitar is now assembled. It goes into a press, then a drying rack for several hours. Next, they glue on a plastic binding to protect the guitar's edges. Then comes a fine sanding. Next, a machine with a special sensor measures the precise angle at which the body and neck of the guitar will later be attached. The angle is critical for sound quality. It drills the holes and sands the pieces accordingly. Next, they apply lacquer, 4 to 8 coats depending on the finish. The fingerboard is made of rosewood or ebony. The metal frets separate the half tones on the musical scale. An adjustable rod goes inside the neck. This lets the neck adapt to the different tensions that different types of strings require. They glue the fingerboard on the neck. Then vacuum press it to make sure it adheres evenly. Next, they install the machine heads on which the strings will be wound. The rod in the neck slips into a groove on the body. The neck is then bolted and clamped until the glue dries. Next, they glue on the bridge, securing it with temporary screws and a clamp. Then they glue on the headstock nut, a hard plastic piece that spaces the strings evenly. Next comes the saddle, then the bridge pins, which lock the strings in the bridge. Finally, they string the guitar using an electric winder. Because of all the glue drying time, it takes 3 weeks to make a guitar. The wood will become suppler the more the guitar is played. So as the guitar ages, the better it will sound. Twisting off an aluminum screw cap may lack the style and sophistication of uncorking a fine bottle of wine. But as devices go, these caps are one of the easiest ways to put an airtight seal on a bottle or jar. And the added bonus is that they're entirely recyclable. There are hundreds of everyday objects that are capped. This plant makes 250 million metal screw caps yearly in 12 different sizes. The caps are made from these 11 square foot sheets of aluminum weighing 1 pound. Some 3,500 thin aluminum sheets pass through this feeder. They begin by coloring the aluminum sheet with a colored varnish, a lacquer, and an ink. Then 12 minutes of drying is needed. The colored sheets set off on a conveyor for drying. Then designs are produced. The coloring is applied by this varnisher. The aluminum sheets pass through the varnisher one at a time. Here we see the sheet printed. Above are the colors used. They are highly colored inks that adhere well to metal. Suction cups grab the sheets and send them toward the transport system of the punch press. This press will give the caps the required shape. But the caps have to be machined in successive steps by molds such as this one. The punches first cut the caps. Over 500 caps a minute can be produced. The blades of the punches are made of carbide, a very hard metal that can cut tens of millions of caps. At the exit point of the punch press, the caps are formed but don't yet have the right dimension. This stretching press performs the last 2 cold forming steps so that the tube will have the required length. Now for the second stretching. This achieves the desired diameter. When the cap exits the press, it will finally have the desired dimensions. At this point, the cap now has the required shape. The caps now have to be decorated to the client's requirements. The lateral imprint is made with this silkscreen type decorator, which colors some 100 caps in 60 seconds. The decorator uses an ink specially formulated to adhere to metal. The caps will then dry in a warm air oven. The dried caps are ejected and fall into a container. This other flexographic type of decorator prints 155 caps a minute. We can clearly see the ink roller, which imprints the side of the caps as they rotate against it in a steady stream. All that's required now is to form the cap and make the cut. The profiling and jointing machine makes the cuts and reliefs on 200 caps per minute. Machining the cap takes but a fraction of a second. They sometimes have to assure the watertightness of a container such as a wine bottle. For this, a polypropylene liner is inserted, which hermetically seals the container. A check is carried out under a light to verify whether the cut has been properly made and the ridges well formed. At last, the final steps. This screw tightening machine hermetically seals the caps onto the bottles. The 250 million screw caps made here each year call for the machining of 1,000 tons of aluminum. In the golden years of animated film, teams of animators would draw every single illustration by hand. Today, they do much of their work by computer, but that doesn't mean it's any less artistic. It all starts with a screenplay, a script containing not just dialogue, but also physical descriptions of the characters and background scenery. The art director begins creating the characters. He draws in pencil. When he's finished, he traces the drawing in felt pen. Then he erases the pencil marks. He adds shadowing to create relief. Once he's drawn all the characters, he starts the backgrounds. And then the objects that appear in the backgrounds. The storyboard artist blocks out the film on paper, drawing by drawing. The production team will follow this storyboard the way a dressmaker follows a pattern. They blow up the drawings, scan them into the computer, then play them back in chronological order. This creates what's called an animatic, a two-dimensional version of the film minus the animation. Should the director now decide to change, say, a ground-level view of the street to an aerial view, he has the artist redraw the street from that new angle. Meanwhile, the animators work on bringing the characters to life. Using specialized software, they build a skeleton to fit inside the character's body. When they move the skeleton, the software makes the body move with it. They make the characters three-dimensional using a technique called wireframe animation. First, they build the shape of the character using a wire structure. Then they add color and clothing. They further refine the character by modifying facial features, by adding texture, and by shadowing. They use specialized software to synchronize the character's mouth with the dialogue. The technician works syllable by syllable, picking the mouth movement that matches each sound. It's a painstaking process that takes many months. Another animator applies the lighting effects. Lighting is as important in an animated cartoon as it is in a movie with real people. It creates relief, making everything look more realistic. The animators cut and paste the characters and objects onto the backgrounds. With the characters' movements programmed into the computer, the animators turn a two-dimensional still version of the film into a three-dimensional animation, essentially a rough cut of the film. Meanwhile, in the studio, the soundtrack takes shape. Actors record the characters' dialogue. The sound technician weaves together the voices, the music, and the sound effects, using specially designed software. They sync the soundtrack to the rough cut of the film. Then they refine the rough cut, playing with colors and textures, and smoothing out the characters' movements. After a full year's work and more than 42,000 drawings, This 24-minute computer-animated film is finally finished. ARC trainers can give you a full-body workout. They provide a number of exercise programs to choose from, like strength training, weight loss, and cardio. They monitor such things as heart rate and calories burned. Like any piece of exercise equipment, using one properly is the key to a safe and healthy workout. ARC trainers are made to give you a wide range of incline and resistance levels to let you train as easy or as hard as you like. To start, a tube laser machine cuts and profiles the steel tubing that will make the ARC trainer side frame. A worker cleans the steel tubes, then runs them through a computer-controlled roll-forming machine. This machine shapes all the steel used to build the ARC trainer's frame. They use a robot to weld all the parts together because robotic welding is more consistent and accurate than hand welding. The completed frames then get a surface preparation, giving the steel a uniform finish that is now ready for powder painting. Workers then paint the frames using an electrostatic paint process. These guns spray electrically charged paint particles that are drawn to the grounded frames in a smooth and even coat. The frames then bake in an oven for 40 minutes to cure the paint. Next come the handlebars. A worker then makes them by lubricating a rubber tube and sliding it onto an assembly frame. He then locks a preformed metal tube in place and lubricates it as well. He turns a hand wheel, which brings the two tubes together, forming the hand grip. He completes the assembly by screwing on an end cap. Meanwhile, a worker assembles the control panel by putting on the overlays for the user interface. She then hooks up the printed circuit board that controls the unit. She closes the housing, but leaves the connectors exposed for connection to the mainframe later. A worker then attaches a steel support fixture onto the frame. Next comes this drive wheel assembly, which he bolts onto the support fixture. He puts a drive belt around a pulley that provides various resistance levels for the user and rolls the belt onto the drive wheel. He then uses a pneumatic tool to tighten down the pulley, which stretches the drive belt and sets it to the appropriate tension. Next, he attaches the computer board that controls the various fitness programs. A worker then installs the leg bars onto the ARC trainer's frame and attaches a foot pedal onto each leg bar. He installs linkage bars onto the drive wheel assembly. Then he aligns the drive wheel and puts on the molded front housing, followed by the protective side covers. He connects a linkage bar that extends from each leg bar to the drive wheel, then connects one linkage bar to each arm handle. He makes sure all the linkage bars are working properly. Finally, he tests the free-floating foot pedals and the dual-action arms, as well as all the other functions and features. These arc trainers are high-tech exercise machines. Some models even come with a TV. Balloons are used to mark special occasions or to brighten up a day for young and old people alike. But balloons weren't always so delightful. In earlier days, they were made of dried animal bladders, a bit of an unpleasant concept. In the 19th century, someone invented a rubber balloon, which we still use today. They started mass-producing balloons in the 1930s, and today they're everywhere. To make balloons, they pour dye into a tank of latex. They filter it through cheesecloth to remove any lumps. Agitators at the bottom of the tank mix it up for 15 or 16 hours. This distributes the color, and it also keeps the latex active so it doesn't congeal. Balloons come in 53 different shades. Nozzles spray hot water onto balloon forms to clean them as they move on a system of rollers. A fixture then flips and dips the forms into a tank of coagulant that carries an electrochemical charge which will attract the colored latex. On top of this fixture are balloon forms freshly dipped in blue latex, while below, a tank full of latex rises, coating more forms on the underside. The job done, the fixture flips back, moving the balloon forms to an upright position, while below, another tray of balloon forms takes the plunge. The latex dries quickly as a conveyor moves the balloon forms forward towards spiraling brushes. The brushes roll up the bottoms of the balloons, creating lips. The lips will make it possible for people to grip the balloons in order to inflate them. The fixture flips again, and the balloons nosedive into a hot water bath. They soak for up to 16 minutes. This step is critical. It leaches out all the impurities, including a protein that causes latex allergies. The hot bath also triggers vulcanization, or rubberizes the latex. The balloons travel to another station. Here, the fixture dips them in a mix of talcum powder and water. This will allow them to be more easily stripped off the form. And now it's time for the forms to shed their latex skins. As the forms pass through this station, air jets inflate the balloons. Rollers at the top grab the balloons as they fill with air and pull them away from the forms. The rollers shoot the balloons upward, and they topple onto a conveyor belt. Next, a worker piles the balloons into an industrial washing machine and adds a cleaning solution. The machine heats to a steamy 160 degrees Fahrenheit, while the balloons tumble and nozzles spray water into it. This doesn't just clean the balloons, it completes the vulcanization of the latex. Now it's time to see if they can stand the test of inflation. A machine blows air into a huge heart-shaped balloon, and the heart swells but doesn't break. She holds it against a light to check for imperfections like blisters. Now it's time to blow some up. They're sure to brighten up your day.